So we're going to start today. We've got a new equation here. The one that we're going to be working on today is the ideal gas law. So the ideal gas law takes the gas laws that we studied, the Avogadro, the combined gas law, Boyle's, all of that stuff, combines it into one equation. And this is the equation, which is pressure times volume equals nRT. And we got to talk about what these different components are. So this is going to take our pressure. And our pressure here is going to have to either be an ATM, kilopascals, or millimeters of mercury. Okay, and I'll show you which one you're going to use coming up here in another minute when we get down to that chart down at the bottom of this page. Volume, which we've already studied as well. I can't spell, I guess. Which has to be in liters here. If it's not in liters, you got to get it there before you can use this equation. Temperature, which has to be in Kelvin. And if it's not, you got to get it there. We talked about how to do that last week. And then it also accounts for the moles of gas or the amount of gas. And that has to be in moles, or it can be in grams, but you have to know the molar mass. All right. So this law only works for ideal gases. That is where your attractive forces between the particles, which we know what as attractive forces between particles, what are those called? IMFs. So your IMFs have to be minimal or non-existent. We are adding in this N variable, which is the moles of gas. All of your other laws that we studied up to this point assumed that you had a given amount of gas and you didn't have to worry about that. But now we're taking that into account. So pressure, volume equals moles of gas times R, which is a gas constant, times the temperature. All right. There are 3 R values that you're going to have for your use. I will give you all equations for this test, and I'm going to give you all of these R values for your test. So you don't need to memorize them. And when you take AP, you should take AP. When you take AP, all of those are given to you as well. Okay? Ideal gases then. So let me go back to this. If your pressure is given an ATM, this is the number you use. If your pressure is given in kilopascals, this is the number you use. And if it's given in millimeters of mercury, this is the one you use. That makes sense? All right. Ideal gases are gases with no intermolecular forces. Ideal gases follow gas laws under all conditions of pressure and temperature. But just as a kind of side note, technically we don't have ideal gases. But in here, we're going to assume that everything is because it makes the math much easier. In AP, you assume everything's ideal as well because it makes the math easier. If you get into college, some advanced courses, then they'll pull that rug out from underneath you. But we don't do that in here. Okay? They give us a good idea of what is happening, though. All right. Gases behave less ideally or more real when intermolecular forces increase. Okay, high pressure. So you're squeezing those particles really tight together. If you squeeze them tight together, that allows those IMFs to start taking effect. Low temperature means that the particles are going really slow, and so they have a better chance of hooking up. Polar versus nonpolar. Polar gases act less ideal because they have a positive and a negative end. They are more likely to hook up. And then larger molecules act less ideal due to their size. Why would larger molecules be affected by this? Go back to last chapter, IMFs. Bigger molecules have more give me a letter.
E.
Nope.
E.
E.
L. T. T. O. R. O. G. Oh, electrons. Oh, she's so good. I like them. I'm good at guessing names.
If they have more electrons, then they are more P. Polarizable, which gives them a greater number of LDFs, and that makes them hook up together, right? Does that make sense?
Yes.
More electrons are more polarizable. All right. Can you use, well, I'm sorry, you can use these to find the number of moles, okay? But you can also rearrange this for finding mass. This molar mass should be over here. So this should read PV equals M, where this is your mass, RT over molar mass. Okay, because remember, moles equal grams per mole, right? I'm sorry, that's your molar mass. Okay, so if this equals grams per mole, if we want to solve for moles, moles would equal mass over molar mass. That makes sense algebraically? What I just did there? So that's where they sub that in. All right, you ready? You ready? You ready? You got your calculators out? Got your periodic tables out? Oh, it's a good time. You ready? You ready? You ready?
Yeah.
All right, we've got pressure given to us. We're trying to solve for moles. So in this equation, PV equals nRT, what value are we solving for? N. Yep. So N is going to equal PV over RT. Do you see what I did? I divided both sides by RT to isolate N. So our pressure is 3.81. My volume, I need to check and make sure it's in liters, which it is. So that's 0.044 over. Now I've got to figure out my R value. So when it comes to figuring out our R value, you need to find the units of pressure. So I found my pressure. That's an ATM. I'm going to go back up to this chart and I'm going to find where that pressure is in ATMs. And this is the value for that. So that's what I'm going to use for my R value. And then my temperature, I need to convert that into Kelvin. And then I just plug and shove. Anybody not know where I got some of those values from? Everybody's cool with those? Happy campers? All right. Let's see if on your calculator, you can end up with the right answer. Remember, when you put this in your calculator, you're going to hit divide here. When you come down here, you need to begin a parentheses so you can multiply these together into your parentheses and then hit equals. So your answer here should be 0.0069, and that's going to be moles of gas. We don't know what gas it is. Okay? Questions? All right, see if you can take this next one and substitute, rearrange your equation like I did here. You're solving for temperature. Let's see if you can get this set up to solve for temperature and plug in your values. All right, got your substitutions in. You should have gotten temperature by itself. You should have had PV on one side and divided by NR here. So your pressure ended up being 143. Your volume was 1 over. Now you had to put your moles down here, and then you had to figure out your R value. So to figure out your R value, you're going to see what units your pressure was given in. You're going to go back to this chart and find the R value associated with kilopascals. So that ended up being 8.314. Then you do the math and you end up with 6.91 Kelvin. Okay, because they didn't want Kelvin, did they? Did you give them what they wanted? Anybody give them what they wanted? Yep. So you have to take this, you have to subtract 273, and you end up with negative 266.09, and that's degrees Celsius. Make sense? All right, what are we solving for here? Volume. So see if you can get your equation set up so that you're solving for volume. See if you can come up with the correct answer for this one. All right, questions on that guy? Anybody not able to get that answer? You okay? No? Okay. All right. See if you can get the next one, or next two actually. See if you can do the next two, and I'll get the answers up for those for you, okay?
Subtract. Divide. So if your transfer for 1 on both sides. On both sides. Be on the left. Good. You, if you want to solve for P, you divide both sides by B. For 3, I got 7.8.
That's what I got.
There. That's what I got.
That was an easy fix.
My haircut on Wednesday, I can't believe it. It's my split ends, it's so funny. Yeah, I was just a trying to get the split ends off. I haven't had it cut since August, so it's time. Mhm. Yeah. Mine's, yeah, I haven't had mine cut since August, so it's time.
All right. Need more time for it? You need to see my work? Good? You got the right answers? Everybody good? Is she just not putting in her calculator?
So what's the pressure? Yeah. And then you have your temperature, you have your
Can you scroll down a little bit?
Hmm?
Can you scroll down that little bit so we can talk? Oh, shoot.
No?
What the heck?
I got 307.2.
Move the decimal place over a little bit.
Is it in Celsius? Yeah. Then you need to
Oh, did I miss a decimal?
Yes, ma'am.
Okay. Oh, Lord, have mercy on my soul. It was a lead. It was a lead. Okay, so how about 307? There. I fixed that one now. My calculator, when it turns itself off, when I turn it back on, a lot of times it will forget that first keystroke. So then what I did was I had 988 in there instead of 0.988. And I'm sure that's what happened with my calculator. That happens all the time. I thought that was a big number. Nobody in first hour questioned me. Just saying. Yep. All right. So now we're going to practice using mass. They're giving us mass, or they're giving us molar mass. We've got to figure out mass here. Okay. So we're figuring out grams. So you can do this a couple different ways. You can do it as PV equals grams times RT over molar mass. So you can do that. Or you could solve for moles and use that with the molar mass to figure out moles. So you've got a couple of different ways that you could do it. Okay. I'll show you here how to do it when we're given using this equation. I'll show you down here how you can do it when you're given if you solve for n, just to figure it out. Okay. So, or actually I'll do that. Yeah, I'll do that down here. Okay, so we've got PV here, and we want to isolate grams by itself. So that means that I'm going to multiply both sides by molar mass. This molar mass will go away, and that's going to give me MMPV equals GRT. And then if I want to get G by itself, my grams, I'm going to divide both sides by RT. That'll get rid of RT here, here, and here. And that gives me my grams by itself. So that's going to give me grams equals molar mass times pressure times volume over RT. So I'm going to sub in my molar mass, which is 70. I'm going to sub in my pressure, which is 117. I'm going to sub in my volume divided by, now I've got to figure out what R value. So I'm going to look and go, okay, this is in kilopascals. I have to use the R value associated with kilopascals, which is what? 8.314, easy as pie. Okay. Times the temperature. So I've got to do 35 times, not times, 35 plus 35.1 plus 273. So that gives me 308.1. Then I just plug and chug into my calculator. I ended up with, and check my math because I have been wrong today several times. And that's going to be grams, and they didn't tell us what kind of gas, so we're just going to say grams of gas. Times 2, 0.014. Oh, yep, there's my problem right there. I had pressed a 7 instead of an 8. Okay, I told you I'd been wrong today. And first hour didn't catch that either. All right, better? All right, so now I'm going to show you how to sub in. This is N, this should be a lowercase 2. My apologies there. We're going to calculate grams of this present. I'm going to show you how to do this. If you didn't want to do it as one fell swoop here and you wanted to do it as 2 steps, I'm going to solve for moles first. And then I'm going to show you how to convert that into grams. Okay? Don't go away. All right, so my pressure here is 1. My volume is 0.6 over. I've got to figure out what R unit to use. Well, this is an ATM. So I'm going to use the R value associated with ATM, which is 0.0821, times my temperature, but I've got to convert this into Kelvin. So it's going to be 295 Kelvin. So 0.6 times, oops, divided by, why did that go up there? That's weird. Why would that do that? Okay. 0.6 divided by parentheses 0.0821 times 295 in parentheses. Check my math. 0.248. And that's going to be moles. Okay. So now I need to get that into grams. So what do we do if we have moles and we want to get it into grams? Well, I'm going to go back to my lovely dimensional analysis. I'm going to get rid of moles and I'm going to go into grams. And I know for every 1 mole, I have 44.0 grams. Where did I get that from? Well, N2 is 2 times 14 for nitrogen. That equals 28. So that's where did I get 44? Oh, God. It is a Monday, y'all. I'm sorry. All right, so I'm going to take that times 28. So I ended up with 0.694, and that's going to be grams of N2. Ugh. All right, you ready for some fun algebra?
Yeah.
Okay. All right, so we've got density here, but we haven't talked about density in this section, and I haven't given you an equation for it. So density equals what? Mass over volume. We have, in this equation, we've got mass and we've got volume. See that? So we've got to rearrange this guy so that mass is over volume, and that's on one side. Okay, so here's that equation again. PV equals mass times RT over molar mass. All I did was rewrite the equation now. So I am going to get molar mass over here. So I'm going to multiply this side by molar mass, and I'm going to multiply this side by molar mass. So molar mass then times P times V equals GRT. Lose anybody with the algebra there? Now I'm going to take RT and I'm going to get it over here. So I'm going to divide this side by RT. I'm going to divide this side by RT. So this RT cancels. That's going to leave me, and I'm going to flip this around. I'm going to put grams over here equals molar mass times P times V over RT. Having fun yet? Now I'm going to get volume over here because remember we need mass, this density equals mass over volume. So I need to get my mass over my volume. So now I'm going to divide this side by V, and I'm going to divide this side by V. So that's going to be grams over volume. Mass over volume is density. That's going to equal molar mass times pressure times volume. Nope, not times volume. Bad lippy. Bad lippy. Volume's canceled there. Divided by RT. And that's my formula for density. Is that fun? That's fun, right? Did you have fun with that? It's fun algebra. I have a different definition of fun than you do, don't I? That's okay. All right, so now we're going to start subbing stuff in. We've got 44 times our pressure. Well, they told us STP. So what pressure do you want this to be in? 1 ATM. That makes math a lot easier. Yep. So she chose 1 ATM. So that means that I need the R value that is associated with ATM. And then I've got to have my temperature here. What is standard temperature? 273. There you go. All right. So we're going to do 44 times 1 divided by 0.0821 times 273. And that ends up equaling 1.96. And what are my units? What was my mass in? Grams. What was my volume in? Liters. So my units are grams per liter. All right, now this kind of becomes our density equation, but they don't want density for this one. They want molar mass. So here we're going to have to isolate this guy. So the first thing I'm going to do is I'm going to multiply both sides by RT. So D RT equals MMP. I need to get molar mass by itself. So what am I going to do? Divide by both sides by P. So I'm going to divide this side by P. I'm going to divide this side by P. My pressures cancel. That's going to leave molar mass equals density RT over P. Let's see if you can substitute in and calculate. You okay? See if you can do number 5 then.